Now that we've gone over the basics of phylogenetic trees, we understand how trees can show us the relationships between animals based off of their physical traits. We're going to take it one step further now. Another way to build a phylogenetic tree is to use molecular data to group species instead of specific traits. Believe it or not, we can actually make a phylogenetic tree from a table that looks like this. Let's work through this table together and build a tree. Now in this example, species X is going to be our outgroup. Now this means that we need to refer to this group every single time. Our outgroup will show us what the sequence was originally, and anything that is different from it will have had a change at some point. So let's find those differences. In number 1, it's an A. So the only one that's different is C. In 2, it's a C. So all of these A's are going to be different. 3 is C. So there are 2 of them, A's. 4 is G. It looks like there's just one down here. 5 is T. So we have K and L that have A's. 6 is A in our outgroup. So T is different, and there are 3 of those. In 7, our outgroup is A, so same thing. We'll find our T's. There are 2. In 8, outgroup is T, so there's only one. That's C. 9, our outgroup is C, so we've got some A's that have had a change. Now that you get the idea, take a few minutes to fill out the rest of the changes in this table. So hopefully it looks something like this when you're finished. Now we can take note of a couple groups, 10 and 11. We'll talk about those later, where they all experienced a change from their outgroup, as well as 20 fits that category. And then as well we have group 21, where there was no change at all, and we'll address those later while we're building our tree. Alright, so now we'll go through each one and we'll group our species together. In our group 1, there's only one trait that's different, so this is uninformative and it won't help us build our tree right now. So we'll go on to number 2. In number 2, it looks like H, I, and M are grouped together under trait 2. So we'll just put them like that. In 3, we have J and O together. We'll bring those over here. Group 4 is uninformative because there's only one. Group 5, we have K and L. Let's bring those over here. Related to trait 5. Trait 6, we have H, I, and M again. So just like number 2. So we'll add trait number 6 to that. Okay, in 7, we have I and M. So it looks like we have a subgroup inside of our HIM group that we've already made. If we look at 8, there's only one, so uninformative. Move on to number 9. We have H, I, M, and N this time. So we'll make a bigger group that includes H, I, and M, and also includes N. So that will be trait 9. Group 10 and 11, we'll come back to those because it includes all of them. And we'll figure that out at the end. Group 12 has changes in H, I, and M, like we've already seen before with traits 2 and 6. There we go. Now group 13 is uninformative again because there's only one. Now group 14, we look and there's I and N. So we say, well, that's confusing. So what we're going to do is we'll just put I and N over here to the side with trait 14. Because we could look at that later and it might come up a few more times where I and N are grouped together, or it might just be a homeoplasy, and so we can put that to the side and address that later. So in group 15, we have H, I, M, and N. So that one can go up here with our trait 9, since it's the same grouping. 16, we have H, I, J, M, and O. So that is going to be all of these groups together. There we go. 17 is, let's see, J and O. So we've seen that before. We have that one right here. Trait 18 is going to be K and L. So we've also had that one before. Stick that up here. Trait 19 is H, I, J, M, N, O. So we just added that one with trait 16. So stick this up here, just like that. 20 we'll go back to. 21 is no one. We'll also go back to that one later. 22 has 1 and is uninformative. 23 is uninformative. So we have 24, which is K and L, which we've seen already. We'll add this. And 25 is also uninformative. So let's move our IN down here to join the rest of our groups. So now let's look at our groups 10, 11, and 20. Now in these groups, it includes every species except for our outgroup. So now that we have all of our other groups down, we can create a group of all of them combined. And that will be for traits 10, 11, and 20. Now to make things easier, I have marked all of the groups that we indicated were uninformative with a red dot on the top of their group, just so it's easier to find them later while we're building our tree. So now that we've found all of our groupings, we can go on and begin to make our tree. Alright, so now that we have our groupings, we can clearly tell which of these are going to go together. So we'll start it with I and M. Clearly those two go together. So we're going to bring in our page here that we'll build our tree on. And you can see that we've drawn a bracket. Now on this bracket we can put our letters I and M because we know that they go together. We also know that what makes I and M go together is trait number 7. So we'll just put that on the tree right there. By looking at our groupings, we can also tell that H is a sister group to I and M. So we'll add our H right next to our IM bracket, and then we can label this one as H. We also know that the traits that put I, M, and H into the same group are 2, 6, and 12. So then we have N, which is also a sister group to H, I, and M. We'll draw on our bracket, and then we can label this one N. Now the traits that N, H, M, and I all have in common are 9 and 15. So we'll put those in right here. Next we have the J, O group, which we can put right next to them as well. So this new bracket is going to be labeled by J and O. And we know that J and O are grouped together by traits 3 and 17. So we'll just put those right there. Now all of these are going to be grouped together by traits 19 and 16. Next we see that K and L are right next to this other big bracket that includes everything so far. So that is going to be a sister group to everything that we've drawn so far, and it should look like this. So this back bracket is going to be KL, and then those traits that make K and L belong together are 5, 18, and 24. We know that all of these so far are grouped together by the traits 10, 11, and 20. So you're probably wondering about this IN group that we have over here, and by the looks of what our tree ended up being, IN is probably a homoplasy. So we're just going to take the trait 14 and we're going to put it on both the I and on the N, just like so. Now we're going to go back and address all of the traits that we indicated that were uninformative because they didn't have enough of the different letters that had experienced that change. All right, so now we'll add on our X group, which you're just going to tag on to the side over here. And we know that there is one trait that every single species had, and this one was trait 21. So we're going to bring that one over here because it even included our out group. Now we'll just go through one at a time with the remaining trait numbers and assign them to their appropriate species. So we have trait number 1, and that one only belongs with I. So we'll bring that one over to go with I. And trait 4 belongs with O. Trait 8 will go with H. Trait 13 with M. Trait 22 is going to be with J. 23 will go with L. And 25 will go with K. So here is your finished tree, and hopefully that made sense to you of how to turn a DNA matrix into a drawn-out tree like such, showing the different characteristics for each species.